Vision math lesson is 15-1 to analyze patterns and relationships. But first, let's do a warm-up. Insert parentheses to make the statement true. Where in that statement could you put the parentheses to make that equation equal 11? Right now, working left to right, 5 plus 7 is 12. Subtracting 9 is 3. Subtracting 8 gives me a negative number. But if I put parentheses in, I can get a solution of 11. That's right. If I put parentheses in between the 9, or around the 9 and the 8, I get a difference of 1. 5 plus 7 is 12. Subtract that 1, my total is 11. An apartment complex has 91 apartments. There are 177 cars in the complex parking lot, which is the best estimate of the number of cars per apartment. To solve this, you want to find a compatible number math fact. Which solution is the correct one? Well, B is brilliant because 177 rounds easily to 180, and then I could divide that by 90 because 18 divided by 9 is 2, 180 divided by 90 is also 2. All right, let's get to our lesson, math patterns. Understanding that a pattern is a repeated design or a recurring sequence. You see these all the time and don't maybe even realize it. But math patterns we have with shapes or with numbers. And today we're focusing on math patterns with numbers, following a rule in a table. Emma has $100 in her savings account. Jorge has $50 in his savings account. They each put $10 in their accounts at the end of each week. Complete the tables to see how much each of them is saved after 5 weeks. But here's the question. What pattern do you notice? So, the rule for the table is adding $10 to each person every week. How much will Emma have after 5 weeks? Yes, she's going to have $150. And Jorge will have $100. But that's not the question. Yes, we need to add $10, but the question is what pattern do we notice? And the pattern here, if I compare the same week for Emma to the same week for Jorge, Emma is always going to have $50 more. Why? I compare the same week because those are corresponding. Week 5 for Emma having $150 corresponds to week 5 for Jorge having $100. If the savings pattern continues, will Jorge ever have as much money saved as Emma? No, because she started with $50 more. If that pattern continues, she's going to always have $50 more. I like to look at the sample work here, and this is kind of just what we did. Juan and Penny both filled out their charts perfectly. What feedback would you give? I agree. Juan answers the question about the pattern, where she's just telling you the rule for the table. Juan is telling you what the pattern is. Lindsay has a sage plant that's 3 5/10 inches tall. She also has a rosemary plant that's 5 2/10 inches tall. Both plants grow 1 5/10 inches taller each week. How tall will the plant be after 5 weeks? What is the relationship of the height of the two plants? So the rule is adding 1 5/10, but that's not what we're being asked. I want to know the relationship. So if I add 1 5/10, after 1 week, her plant is 5 inches. After 2 weeks, it's 6.5. How tall will Lindsay's sage plant be after 5 weeks? Yep, after 5 weeks, her sage plant will be 11 inches. And if we look at the corresponding data on the rosemary plant, we notice a difference. So if her plant is 11 inches after 5 weeks, and the rosemary plant, is 12 and 7/10, I notice that rosemary plant is always 1 and 7/10 taller than the sage plant, because that's what they started at. That's my pattern. And this corresponding term, week 1, her sage plant is 5 inches. Week 1, the rosemary plant is 6 and 7/10 of an inches. It always has a difference of 1 and 7/10. Let's have you try this. What if the rosemary plant grows 2 and 1/10 inches taller each week? Fill in the table. How tall would it be in week 2? Yep, 2 and 1/10 inches each week means that at week 2, it would be 9 and 4/10 inches. What about week 5? You got it, 15 and 7/10 of an inch tall. Well, it looks like you have this down pat. So go ahead to your practice buddy and do your work. Thanks for listening.